Hello children, in a previous video we discussed about pulleys and types of pulleys. There we discussed about single movable pulley and single fixed pulley. Dear children, what is the mechanical advantage of single fixed pulley? The mechanical advantage of single fixed pulley is 1, whereas the mechanical advantage of single movable pulley is 2. But dear children, in order to lift heavy loads or else in order to carry the heavy load from one place to another place, we need a we require a system should have mechanical advantage greater than 2. But children, by using single fixed pulley or single movable pulley individually, we cannot attain the mechanical advantage greater than 2. So for that only, what we will do? We are going to combine the pulleys. So children, here we have two methods to combine the pulleys. So in this video, we are going to discuss what are the two methods to combine the number of pulleys and how can we increase the mechanical advantage by using that combination of pulleys. So in that, children, the first one is one single fixed pulley and several movable pulleys. Actually, we have two methods. So the first one is one single fixed pulley and combined with several movable pulley. And the second method is block and tackle. So first we will discuss this method, then we will go for block and tackle. So dear children, in this single fixed pulley and several movable pulley, so how can we calculate the mechanical advantage of the system and how can we calculate the velocity ratio, and moreover we can understand how we are going to increase the mechanical advantage. Children, first suppose dear children, here look at this picture. In this A, B, C, D, 4 pulleys are there. But here we have to notice one very important thing. What is that here? Except D. So D is single fixed pulley. D is single fixed pulley, but whereas other three A, B, C, these three are single movable pulley. So this is a combination of one single fixed pulley and 3 movable pulleys. Dear children, this can be 4 movable pulleys, 5 movable pulleys, depends on what is the mechanical advantage, what you want to achieve actually. So depends on that, we are going to increase the number of movable pulleys. So for this system, dear children, how can we calculate the mechanical advantage? So once again, if you want to calculate this, before going to calculate this, let us recall once single movable pulley case. Then only we can understand this very easily. Children, the case of single movable pulley, so here is a system. So here is this what actually single movable pulley which we have. So here is load. Here is load. So here is the effort. Effort is balanced by tension and this is balanced by tension. So children, here load is balanced by 2 tensions. Am I right? So whereas effort is balanced by tension only. So this is a very important clue which we have to remember in order to understand this system. So the first one. Whereas always the effort is displaced by twice than that of the displacement of the load. So here effort displacement is always twice the displacement of the load. So if you can, children, it's very simple. This is the point which we are going to apply for each and every pulley in order to attain mechanical advantage and velocity ratio. Children, in this diagram, just you need to notice one very important thing. Here, 3 different stringes are there. Children, as long as the string is same, the tension throughout the string is same. But here, we are using 3 different strings. So, the tension in a different stringes will be different. For suppose, dear children, in this it is T1 in this string. If it is a T1, then in this second string tension will be different. So let us take it as a T2, so that it also will be T2 only. So in the third string the tension will be T3. Let us take here is a T3. So here also T3, and this is the third string only. Here is a T3 only. And dear children, this is the point where we will be applying the effort vertically downwards. And as usual, load direction, of course, load may move vertically upwards, but load direction is always vertically downwards only. Now first let us calculate the mechanical advantage. Children, first let us calculate the mechanical advantage system. So here we know that mechanical advantage is equal to load by effort. So here we need to calculate the load value and we need to calculate the effort value. Then we will substitute, we will get the mechanical advantage. Children, no doubt about it, here effort is balanced by T3, that is fixed. So here effort is equal to T3. Effort is equal to T3. But teacher, in this diagram, here is a load. So load is balanced by tensions in a two segments of this first string. So L is equal to T1 plus T1. So that will be 2T1. So let me write here. L is equal to, it is 2T1. It is fine. But whereas dear children, it is over. For A pulley, it is over. For a B pulley, this T1 is balanced by the segments developed in these two segments of the second string. That is, T1 is equal to T2 plus T2. So, what can we write here? T1 is equal to 2T1. Sorry, T2 is equal to, T1 is equal to, it will be 2T2. T1 is balanced by this 2T2. But whereas, in the case of third pulley, that is pulley C, in this case, dear children, this T2 tension is balanced by these two segments, the tensions developed in these two segments of the string. That is, T2 is equal to T3 plus T3. That is how much? T2 is equal to 2T3. So, dear children, here it is T2 is equal to 2T3. Now, what we have to do? This T1 value you substitute here. So, what do we get here? T is equal to 2T2. So, that is 2 into 2 will be 4T2. And in the place of T2, dear children, you substitute 2T3. So, this you are going to get 2 into it is 2T3. So, children, here we got here E is equal to T3, but whereas here load is equal to E into T3. So, this can be written as 2 power 3 T3. Now, let us calculate the mechanical advantage. So, here mechanical advantage is equal to load by effort here. So, load we got 2 power 3 into T3 by it is T3. T3 gets cancelled. Then here mechanical advantage we got 2 power 3. Children, here 2 power, this 3 represents number of mobile pulleys. Here because 3 mobile pulleys are there, we got here 2 power 3. Here if we have 4 mobile pulleys, here we will get 2 power 4. If we have 5 mobile pulleys, here we get 2 power 5. Which means what? By increasing the number of mobile pulleys, we can increase the mechanical advantage. Like the picture, if n number of mobile pulleys are there, then what is the mechanical advantage? Then here mechanical advantage is equal to 2 power n. Children, this is mechanical advantage of this system. Here n is what here? N is number of mobile pulleys. Just you copy this, then we will calculate the velocity ratio of the system. Now let us calculate the velocity ratio of the system. So how to calculate the velocity ratio of the system? Just look at the children. So first we know that velocity ratio is equal to effort displacement by load displacement. So what we have to do? Just we have to calculate the effort displacement and we have to calculate the load displacement. Which in the previous session also which we discussed, in the case of single movable pulley, if load is raised by, for suppose here is a load is raised by x displacement. If here L is equal to x, then what will happen here? This A is raised by 2x. Let us say here pulley A is raised by 2x, that is double. Okay. Then if A is raised by 2x, dear children, what about B? B will be raised by double than that of the 2x. That is, B is raised by 2 times of this 2x. So this is a displacement of the pulley B vertically upwards. As B pulley is raised by 2 times of 2x, that is, we are getting it as a 4x. Then what about pulley C? It is raised by double displacement, double than that of the pulley B. So that is, pulley C is raised by 2 times of this 4x. So this will be 8x. This can be written as 2 power 3. It is 2 power 3 than x. 2 power 3 into x. So when pulley C is raised by 2 power 3 into x, then what will happen, dear children? By same amount, effort is displaced vertically. It is displaced by same. That is how much? 2 power 3 times x. 2 power 3 times x. It's a very important. Now here effort displacement is how much? 2 power 3x. What about load displacement? Load displacement is x. That's it which we got. Now you substitute this. So we get here velocity ratio is equal to 2 power 3 x by x. So x get cancelled. So it will be 2 power 3. 2 power 3. So here why we got here 3? Because here we have 3 movable pulleys. Here if 4 movable pulleys are there, 2 power 4 we will get. If 5 are there, 2 power 5 we will get. Like that, if n number of movable pulleys are there, then we get velocity ratio as 2 power n. Which is very important. 2 power n. So what is n, children, here? N is we calculated for mechanical advantage. Even mechanical advantage also we got 2 power n only. So here we got mechanical advantage also 2 power n. So what is the efficiency? Efficiency is equal to mechanical advantage by velocity ratio. So this will be 2 power n by 2 power n. Both gets cancelled. Then what is the efficiency value? It is 1 or it is 100%. It is 100%. In this case, what is the mechanical advantage? 2 power 3, that is 8. What is the velocity ratio? 2 power 3, it is 8. So this is how can we calculate the mechanical advantage of the single fixed pulley and several mobile system case. Now next we will be calculating the block and tackle system. Just you copy it, we will move into block and tackle. Now we will discuss block and tackle system. Children, before going to calculate the mechanical advantage and the velocity ratio of the block and tackle system, let us try to understand what is a block, what is a tackle. Children, if you can see here, all pulleys, how we are going to arrange? The different pulleys are arranged in different blocks. Some metallic frames will be there. Metallic frame. Just you can imagine nowadays almost all we have apartment culture. So there also we will be having different blocks we will be having. In different blocks, again different flats will be there. Like that. So in each and every block, we are going to arrange the number of pulleys. So first of all, what is a block means? A block is a metallic frame. So metallic frame in which pulleys are arranged. So here we will be having 2 blocks, children. Here we will be having 2 blocks. Lower block. Children, here upper block is fixed. Upper block is fixed one, whereas lower block is movable. So this is all about actually what block is. Block is simply metallic frame in which pulleys are arranged. Then what about tackle? Tackle is a string which connects the number of pulleys in a different blocks. I repeat once. What is a tackle? Tackle is a string which connects number of pulleys in a different blocks. Now let us see. Here we have 2 cases. What? Block and tackle system with even number of pulleys or block and tackle system with an odd number of pulleys. If it is a block and tackle system with an even number of pulleys, no problem at all. The number of pulleys in the upper block are equal to the number of pulleys in a lower block. But the problem is that when there are odd number of pulleys, if there are odd number of pulleys, how the pulleys are divided? For suppose here in upper block n pulleys are there. In lower block n minus 1 will be there. Which means what? The number of pulleys in upper block is always greater by 1 pulley than that of the lower block. And here one more very important thing what we have to notice is that if there are even number of pulleys, the hook will be attached to the upper block. Hook is attached to upper block, which means what? The second end of the string is going to be connected to the upper block only. But whereas if there are odd number of pulleys, the hook will be connected to the lower block. Now what we are going to do is that first we'll try to calculate the mechanical advantage and the velocity ratio for this number of pulleys 3. The number of pulleys 3. Then we'll go for this 4 number of pulleys also. So now let us try to connect the strings here. So this end will be connected to here and hook. This is what very important. As I told you that dear children here, whenever there are odd number of pulleys, the second end is connected to the lower block pulley. Dear children, here these all pulleys are connected with the same string, which means what? In a different segments of the string, the tension will be same only. That we have to show the direction. So dear children, here load is always vertically downwards, and this is a point where we are going to apply effort. So that this effort is balanced by tension T. So similarly, dear children, in each and every segment, a tension T is developed. And here also tension T is developed. Now let us try to calculate the mechanical advantage and velocity ratio for this block and tackle system in which 3 pulleys are there. So dear children, so first here mechanical advantage is equal to the load by effort. Dear children, here in equilibrium, this effort is balanced by tension. That is here E is equal to T. And then what about load? Children, it's very important. What is it here? The load is balanced by the number of segments of the string. That is the tensions which are developed in the number of segments of the string. So here one load is acting downward, children. So how many segments are there? 1, 2, 3. So here load is equal to 3 T's. I repeat once here. This load is balanced by the tensions developed in this number of segments. Here how many segments are there? 1, 2, 3. So 3 T's. So therefore here load is equal to, we got it as a 3T. So here mechanical advantage is equal to how much, children? Mechanical advantage is equal to 3T by T. T gets cancelled. So here mechanical advantage is equal to 3. So this is how we can calculate the mechanical advantage. But how to calculate the velocity ratio? This is mechanical advantage which we calculated. Now we are going to calculate velocity ratio. Children, velocity ratio is equal to what? It is a ratio between effort displacement to the load displacement. Effort displacement to the load displacement. Dear children, if this load is raised by x, then what will happen, dear children? Each segment is loosened by x. That is what let us say the first segment, second segment, third segment. This first segment is raised by x only. The second segment also raised by x only. The third is raised by x only. In total, what will happen? X plus x. So 3 times, the 3x times, the effort is displaced downward. It's very important. So here, if load is displaced by x, then effort is displaced by 3x. That too downwards. Now look at here. That is here 3x by x. X cancel. So it is velocity ratio is equal to, it will be 3. Velocity ratio is equal to 3. So this is what mechanical advantage and velocity ratio. So and simply in ideal case, velocity ratio will represent the number of pulleys, not movable pulleys, the total number of pulleys. So in exam, how the question will be given, they'll ask us to draw the block and tackle system with velocity ratio 3. Dear children, as a velocity ratio 3 is given, what you have to understand? Okay, there are 3 number of pulleys. If velocity ratio 4 means what, dear children? There are 4 number of movable pulleys. Just you copy this. Now look at this, dear children. Here it is what actually in exam how the question will be given. They'll ask us to draw the block and tackle system with velocity ratio 4. Velocity ratio 4 means what? You have to think. We have to think that there are 4 number of pulleys, which means what? It is an even number of pulleys. Dear children, there are even number of pulleys. Then definitely upper block means the number of pulleys in the upper block are equal to the number of pulleys in the lower block. And one more very important thing is that whenever there are even number of pulleys, the hook must be connected to the upper block only. Now let us try to connect these two blocks with a string. So here is this what actually the end, and this end we are going to apply the effort. From here dear children, now you take a string to go to the hook. So this is how actually we can connect the number of pulleys in a different blocks. Now dear children, look at here. So as said that this is a point where we are going to apply the effort, and load direction is always vertically downwards only. This is load direction. Dear children, so whenever load is attached, then what happens? The string is tightened. So which means what? Tension is developed in each segments of the string. As it is only single string dear children, the tensions developed in a different segments of the string will be same only. That is, in this it is T only, it is T only. Now how to calculate the mechanical advantage? So first we have to calculate the mechanical advantage. Children, mechanical advantage is equal to load by effort. Children, from that figure here, effort is balanced by tension. So that is what here, E is equal to T. E is equal to T. Then what about load dear children? Here again I am saying you, it's a very important thing to notice. What is that here? Load is balanced by the segments of the string. How many segments are there? 1, 2, 3, 4. Which means what? 4 T's. That is, load is balanced by these 4 T's. T plus T plus T plus T. That is 4 T's. So then L is equal to T is 4T. Substitute in this. So what do we get here? Mechanical advantage is equal to 4T by T. T cancel. Then here mechanical advantage is equal to 4. Mechanical advantage is equal to 4. Then how to calculate the velocity ratio? Velocity ratio is equal to effort displacement by this load displacement. So similarly in the case of velocity ratio 3, how we discussed here also same concept. If this load is displaced by x vertically upwards, then what will happen? Each segment of the string is loosened by x. It is x. Then what will happen dear children? It's a very important thing is that here x plus x plus x plus x, 4x, that is your effort will come downwards by 4x. So here effort displacement will be 4x, load displacement will be x cancel. So here velocity ratio is equal to 4. Velocity ratio is equal to 4. That's it. Dear children, if there are n number of pulleys, let us say, if there are n number of pulleys, then how to calculate the velocity ratio? Here load displacement will be x only. But if there are n number of pulleys, then what will happen? Effort is displaced by nx. So here x cancel. So here mechanical advantage you will get n only, and the velocity ratio also you will get n only. But dear children, this is strictly in the case of ideal pulley system only. In the case of only ideal system only. If not, you cannot get mechanical advantage equal to velocity ratio. Mechanical advantage is always less than that of the velocity ratio only. So children, this is how actually we can calculate the mechanical advantage and velocity ratio of the block and tackle system. Children, once again I am saying you why we need to combine the pulleys in order to increase the mechanical advantage only. So there we discussed two types of combinations. One is single fixed pulley with several movable pulleys, and second one is block and tackle system. In block and tackle system, children, we discussed even number of pulleys case, and we even discussed about odd number of pulleys case. Okay children, thank you so much. All the very best.